Hi, everybody. I thought it would be helpful maybe to some of you if I worked through some dimensional analysis problems. If you're having any trouble with this, I would encourage you to watch this, okay? I'm actually going to work through some dimensional analysis problems that I did not assign to you. So, anyway, this is on page 18 of the worksheet packet that I handed out. And I'm going to skip ahead to number 6. Okay, so let's take a look at number 6 together. So in problem number 6, this person apparently likes milk, and they drink about, 0.00681 kiloliters per day. How many gallons is that? Okay, so we're going to be doing a number of conversions, and I'm going to set this up as one string of conversion factors in order to solve this. So we're going from kiloliters to gallons. What are we given here? What do we know? What are we trying to do? We're given kiloliters, but we're given some information here. There's an equivalency between gallons and liters. We can use that. So I'm thinking about what I'm going to do. I'm going to convert from kiloliters to liters and then to gallons. And I'm looking at our problem here, and I think that's going to do it. Yeah. That is going to do it. So there are going to be two conversions that I'm going to do. Let's set this up. All right, I'm starting with 0.000681 kiloliters. Guys, there are 3 significant figures in that measurement. We're going to stick to those 3 significant figures in this problem, okay? First thing I need to do is convert to liters, so then I can convert to gallons. So for every 1 kiloliter, I know that there are 1,000 liters, right? I set up that conversion factor. This is a conversion factor. I set it up so that kiloliters cancels out. Kiloliters cancel out. What I've just done here is I've calculated liters, even though we haven't done the numbers. We've just worked through the units. The units, guys, are more important than the numbers. Okay? So now we're going to use this conversion factor to go from liters to gallons. I'm told that 3.785 liters, 3.785 liters is 1 gallon. Liters will cancel when I set it up like that. And now my answer is going to come out in gallons. Okay? Let's work this out. All right, my calculator is giving me this. I'm just going to do this. I'm going to put 1.7992074. That would be gallons. Okay? I'm doing this on purpose to show you that I don't like that answer. I'm going to make this answer, I'm going to write this answer, in 3 significant figures. All right, I changed this answer to my answer in 3 significant figures. Now, if you look at the answer that my calculator gave, I've got 1.7992, okay? Looking at the 2 9s here, right? I want 3 significant figures, so that last 9 has got to go. I'm going to round that 9 to the left up to 10, right? So that's going to make that 80. So 1.80 gallons. I'm looking at number 5 now, and I'd like to try that one with you guys, okay? So this is a really good problem to look at because I've got to emphasize, I can't emphasize this more, you've got to always be aware of units. I've said it before, I'll say it many times, the units are more important than the numbers. focus on the units. In this problem, there's two problems here. We're trying to find the area of this rectangle in square centimeters. Okay? I'm given one measurement in centimeters and one measurement in millimeters. Okay? So I'm going to change that millimeters to centimeters. I'm just going to move the decimal point, and I'm going to say that's 3.51 centimeters. Okay? I don't even know if I really need to finish this, but I'm pointing this one out because it's one example where we've got to be very careful about units. All right? So here, I'll work this out. All right, so I worked this out. My calculator is giving me this. 307.4409. That's square centimeters, just like they asked for. But I'm going to convert this to 3 significant figures because the measurement with the least number of significant figures has 3 sig figs, okay? So I'm going to round this now. The only correct answer to this problem is 307 square centimeters. Okay? You're probably thinking, do I always have to worry about significant figures? Most likely you will always be told when we're looking for sig figs, but I gotta tell you, it never hurts to do that. And I think on this upcoming test, you really should be thinking in terms of significant figures, especially when we're talking about measurements, all right? I'm going to say that again, especially when we're talking about measurements, okay? All right, the next thing I think we'll work on together is number 8, all right? This is a more complex problem. We've got literally 2 units that we need to convert. We need to convert meters to kilometers and seconds to days. Okay, so let's start this. I'm going to first write out 465 meters per second like this. Okay, so for every 465.0 meters traveled takes 1 second. Okay. Let's convert meters to kilometers. I'm sorry, scratch that. We're gonna convert meters to miles first. Okay. Now, in order to do that, we're gonna need to use these conversion factors. Meters to miles. Oh, hey, right there. We're actually given a very simple conversion factor right there. So let's go with that. So meters to miles. Great. Oh, I forgot to. So it's 1609 meters per 1 mile. 1609. For 1 mile. All right, great. So I guess this isn't going to be that complicated. Sometimes we have to do more converting in order to get from meters to miles, but we were given the right conversion factor right off the bat, so that's great. All right, what about seconds to hours? All right, I'm going to do this first by converting seconds to minutes and then minutes to hours. Okay, so seconds to minutes. There are 60 seconds for every 1 minute. Okay, I set that up so that seconds will cancel out. I know that there are 60 minutes. Whoops, minutes. Okay, 60 minutes in 1 hour. All right, so minutes cancel. All right, now, guys, remember what I said about units. They're the most important thing. All right, take a look. We've solved the problem because our answer is going to come out in miles per hour. The rest is just multiplication. My answer is 1,040. I'm going to write all these digits out, and then we'll deal with what's left. 397,763. Okay, that's ridiculous, right? This is going to be miles per hour. Okay, now we are given a number in 4 significant figures. I want my answer to be in 4 significant figures. Okay, 4 significant figures. All right, that's going to change to 1040 miles per hour. That's the answer. All right, imagine. Well, I'll tell you, this is true for people that live on the equator. They are spinning around the Earth's axis at about 1,000 miles per hour. We, in the Chicago area, are moving around the Earth's axis around 800 miles per hour. Fun fact. All right, guys. I think I'll leave it at that. And if you need more help with this, if you need more help with dimensional analysis, please see me. Also, don't forget to compare your answers against the answers that are posted in the student resource folder. Thank you.